Welcome back. We were having a question that we posed while we are about to solve it. It says an electrical device is rated 220 volts and 1850 watts. Remember, we said the rating on devices, this will be my VRMS and this one will be the power average. That's what you should know. The rating on the devices, so it's not maximum, it will be the average power and the VRMS. So the first question, they say define the term root mean square voltage. Define VRMS. We just said it to say VRMS is an AC voltage that dissipates the same amount of energy as DC voltage. Get 2 marks for saying that. Number 2, the question says, continue. Calculate the following. Calculate the root mean square current passing through the appliances when it is operating. Find the IRMS. Therefore, we are given power average and VRMS. Go to the list of formulae. We find that there's a formula which says P average equals to VRMS multiplied by IRMS. Average power is given is 1850, and then the distance root mean square voltage is 220. We are calculating the root mean square current using your calculator. You will find that now the root mean square current equals to 8.41 amperes. You can verify that one with your calculator. Then the next one, which is the last one in this question, they said calculate the resistance of the device. In this case, we've got many options. Let's go for the easiest one before also dealing with the other options. Now the easiest one will be resistance equals to, using Ohm's law, VRMS divided by IRMS. We can substitute. We'll find that VRMS is 220. IRMS we just calculated 8.41. Then don't be afraid. In this case, even this one is not 8.41, and you use it here, we'll get full marks for that usage of this incorrect one in this case. And then when you use a calculator, you find that the resistance is 26.16 ohm. Or another learner can use another formula. They say P average equals to VRMS squared divided by R. The learner would be finding 220 squared divided by, let's do parallel. It will be 1850 equals to 220 squared divided by R. Therefore, also with your calculator, you still get the same 26.16 ohm. Another learner can also manipulate this and say, again, I can use P average as IRMS squared multiplied by R, which makes 1850 equals to 8.41 squared multiplied by r. Also r will give you the same 26.16. So you've got many options in this case, 3 options to get to the bottom of this one. So hopefully you understand this one, and you can also solve similar problems that are involved in this section. Is one of the easiest, with only 6 formulae to choose from that are closely related. So let's pause for now. I will come up with another structured question, standardized, taken from the past papers, where now we can also deliberate on it and find how can we easily solve problems in relation with electrodynamics. Very easy. Don't forget that the principle in generators is the electromagnetic induction, and generators in terms of rotation of the coil in the magnetic field. So the generator will follow the direction of current. If the current is clockwise, also the rotation will be clockwise in the generator. In a motor, if the rotation is clockwise of a current, the motor or the coil will rotate anti-clockwise. And also one other thing is about the factors that increase or decrease the EMF using Faraday's law. Remember, it's all about the number of turns, or the area of the coil, and also the strength of the magnets and the speed of rotation. Those 3 will, if adjusted, will end up with a new value of EMF. So that is all for now. Thanks.